Okay, problem number 6. On this one, we are wanting to solve for milliliters. And the thing you want to remember here is that if you reconstitute a medication, if you add a liquid and a powder together and it's a volume that's bigger than it was before, you want to use the resulting volume. And in this case, that becomes 6.7 milliliters. Again, we're matching the numerators. In that, we have 2 grams of medication. We have a conversion in here of 1,000 milligrams to 1 gram. When we cross this out, after we put the 500 milligrams in there, our dose we're going to be giving, then we have what we're solving for. We can cross 2 zeros out up here, 2 zeros down here, which just makes it more manageable to do some mathematics there. So after we do that math, it comes out to 3350 over 2,000, which is 1.67. Now, we're always rounding to tenths, so the answer here is 1.7 milliliters after rounding this. Okay? All right. Number 7. On this one, we're solving for milliliters per hour. So we have 250 milliliters that we want to give in 60 minutes is what our order reads. And in order to set our pumps are always milliliters per hour, or not always, but in this case. Then our conversion, 60 minutes is 1 hour. So we can cross out the minutes. We have a 60 on top, we have a 60 on the bottom. We can cross that out. So we have 250 left. So our answer, 250 milliliters per hour. Okay. That was number 7. Number 8. Here we're wanting to give 1,000 milliliters over 6 hours. So we're wanting to know what to set the pump at. So again, milliliters per hour is what we're solving for. We know that we want to give 1,000 milliliters in 6 hours. So we have our factors right here. We need to do no more. So when we do that math, divide 6 into 1,000, we come up with 166.66. So we round that to 166.7 mils per hour. Okay, so that's the answer there. We would set the pump at 166.7 milliliters per hour. Number 9. Here we're wanting to know how many drops per minute that we're going to give. So on this we know that we have a tubing that has a drop factor. That little chamber, 20 drops will make 1 milliliter. So we have to match our numerators, so we start with drops. We know that there's 20 drops. That 20 drops makes 1 milliliter. We have 100 milliliters we want to give. We want to give that over 45 minutes. So we have everything that we're looking for there. When we do the math, we have 2,000 divided by 45. We come out to 44.4, but we can't have a part of a drop, so we round that to 44 drops per minute. Okay, so that was number 9. Okay, number 10. On number 10, same thing. We have a drop factor of 10 drops per mil this time, and we're wanting to know how many drops per minute to give. So we have our drops per minute. GTTS is drops. We have 10 drops, equaling 1 milliliter. We're wanting to give 325 milliliters over 3 hours. We need to convert our hours to minutes, so we know 1 hour. Again, we're matching these factors to 60 minutes. So that we come out to 18 drops per minute. Okay, that's number 10. Number 11. For that one, we're wanting to know how many milliliters per minute to give. We have 4 milliliters of fluid that contains 80 milligrams. In our drug reference, it says that we shouldn't give over 20 milligrams of Lasix per minute. So here we have our 20 milligrams per minute that we're wanting to give. We have all our factors there. We have milliliters per minute that we're solving for. We can cross that out. We have 8 over 8. So we're not going to want to give more than 1 milliliter per minute. And we'd watch our watch as we're pushing that medication in for that patient and count and make sure we're giving 1 milliliter per minute. Okay, that's number 11. Number 12. On this one, we're wanting to know the maximum amount given per dose. So the amount that we're after is milligrams. We're wanting to know per dose, and you can see here that we have the dose as every 12 hours, so we'll need to factor that in as well. So on number 12, we start where we're wanting milligrams per dose. So we know that we can give 3 milligrams for each kilogram that this child weighs. We have our weight in pounds, so we have to have a conversion in here. 1 kilogram is 2.2 pounds, and this is a pound sign, so we know that's 2.2 pounds. Our child weighs 38 pounds. That's given usually in 24 hours is what our order reads, but we're going to give it every 12 hours. So we have 2 doses. You could also just have it divided by 2 on the bottom 2, put 2 doses. But this way, we know that we're going to give it every 12 hours, and that equals 2 doses. So when we do the math, we come out with 1368 over 52.8. So when we calculate that, it comes out to be 25.9 milligrams per dose. So that's our answer on that one. Okay, number 13. We're wanting to know the percent of weight loss that this baby has had. So it weighed 8 pounds 3 ounces at birth. So we want to change the 8 pounds 3 ounces to just ounces. So we have 131 ounces that the baby weighed at birth. The baby then weighed 7 pounds 12 ounces. And that is 124 ounces. So our difference, what the baby has lost, is 7 ounces. So this is the difference, and we want to divide that 7 divided by 131. So this comes out to 0.053, and it's per cent, so we're taking that times 100. That's what per cent 100 means. So the amount of weight that the baby has lost is 5.3%. So take the beginning weight, the weight that you have, the difference, and divide the difference by the beginning weight, and you'll come up with the percent every time. Okay, number 14, pretty straightforward. We just have to read the order there. The sliding scale says that the patient's blood glucose is 289. So we read it there, and it says give 6 units of insulin. That one's pretty straightforward. Number 15. We have a heparin drip going here. We want to know the units per hour that this patient's receiving. Our pump is running at 18 mils per hour. We know that we have 25,000 units in 250 mils of fluid, and it's going at 18 mils per hour. And when you do the math there, it comes out to 1,800 units per hour is what our patient's receiving. Okay, number 16. On this one, we're wanting to know milliliters per hour. So we start with 100 milliliters that has 1 gram in it, and we have to have a conversion, so our 1 gram is 1,000 milligrams. We're giving 25 milligrams per hour. Again, you can cross these out. 0, 0, 2 zeros up there, 2 down there. So you have 25 divided by 10. So this comes out to 2.5 milliliters per hour. Okay. All right, this next one, number 17, is a little more complicated. When you look at that, the first part of it, you see that our drip is running at 8 milliliters an hour, but we don't know what the units per hour is. So that's what we have to solve for first. we have to solve for the units per hour, and then once we do that, we